I start with something. It is already new for you, known for you. So if you are taking any mechanics systems, they are a variety of problems are available. So some very fine particles to some bulk particle and also some huge particle like sun or Mars system. So if you are taking a small particle like electron or neutron, their velocities are different and also mass is different. And if you are taking a classical, is in general where we are living in the world, like our mass, our velocity, or what we are traveling as maximum using some aerojet planes or something, it will be around 1,000 or 1,000 kilometers per second or something else. So our speed is also limit and our mass is also something like a few kgs. And whatever object we are utilizing, that will be in the order of from a few milligram to some few kgs. For that you are utilizing in your daily life. But apart from our real life, there is huge variations are there that maybe we are not seen. That is not mean that there will be another that particle not exist. There will be some other particles also exist. Like if you are taking electron, neutron, or proton, there will be some fine mass and velocity with the speed of light. It will be there. That their uh, world is different. What we are living. So we will try to separate to them and we are trying to give some mechanism such a way that they can also uh, that behavior we can also known to us, right? So they are based on the simply based on the speed and the size. There are four mechanics are there. So one is the classical mechanics, that what we are living in the world, that is whatever we are seeing or whatever we are going together. And apart from that, if you are going to size to the down, that will be in the order of some pico nanometers or picometer or nanometer or some femtometers. There, apart from size, the size is also reduced. There will be some other phenomena you should learn. That will be known as a quantum mechanics. And if you are taking into the size and speed, then the quantum field theory is there, and it is also on relativistic mechanics is also there. Nowadays, another theory is also proposed, that is a string theory, where many dimensions also exist. All these mechanics are trying to understand the behavior of that particular system in their whole world. For example, if you are living in the southern part of India, then you should need a different language to arrive at that particular location. If you are going to the northern part of India, you will also know some other languages like Punjabi or Hindi or some Marathi or whatever it. You should need to know to arrive to there, right? So that language means you should communicate to the people, and we are trying to get something like that. Here also, if you are living in the classical mechanics, you should need some rules and regulations on such a way that you should learn the basic phenomena or basic behavior of that particular objects. And like in your quantum mechanics also, we should follow certain set of rules. Then you can identify the behavior or the mechanics of that particular object. Like in language also, you have a different set of rules, regulations are there. That is known as a grammar, right? So you should follow the grammar and you should make the statement, and you can express your feeling in a different languages. Like here also in mechanics, whatever the mechanics it is, you should follow certain set of rules, and that rules you should follow accordingly whatever they are giving, and then you should know what is the behavior of that particular object, and you can understand the equation of motion of that particular system at a different mechanics, whatever it will be. So if you are taking the classical mechanics, it will be two things. It is came from the Newtonian mechanics. There is no doubt at all. It is and all together is coming from the Hamiltonian action principle. That is the origin for the a classical mechanics or a quantum mechanics, whatever it is. So in case of a classical mechanics, if you are taking, again, it will be brought into the two categories. One is a Hamiltonian, another one is a Lagrangian Hamiltonian, another one is the Lagrangian mechanics. So both are depending on the action principle, action angular principle, action principle of least action, so called. And this also, Lagrangian is also, you can also derive from the D'Alembert principle. It is also known as a Newtonian second law. Okay, Newton's second law. So F is equal to ma, then simply you can write down this is a simple formula where you can use as a the force acting on the system that can be exhibit some acceleration to move in a forward or backward direction based on the what direction you are applying the force. So base our set of rules came from this Hamiltonian as well as a D'Alembert principle. From these rules, we are deriving some equation, a simple equation that is known as a Lagrangian equation, and that have some set of again we derived some different equations. So that we will see later. And then also Hamiltonian is based on the some energy quantity we are deriving on. From that energy quantity we are making some set of another rules of equations. That is also give the equation of motion of the particular object. So once you can solve these equations of motion, that you can get the solutions of that particular motion of the object. Our ultimate goal is how that object is behaving when you are applying some force, or whether it is a force is a constant force or it will be a non-constant force. If a constant force, then you can so called a conservative force. If it is a non-conservative force, then it is maybe varying with the time. Force is varying with the time. So then this equations of motion is also came from the Newtonian mechanics also. In BSc, we already learned about the Newtonian mechanics. There is no doubt. So based on the Newtonian mechanics, we are deriving a n set of equations and we are follow some equations of motion of that particular object. Right. So why we need this Lagrangian and Hamiltonian? You already learned because you already seen in their MSc course syllabus. So I'm not going to in depth of that particular one. So main reason is whatever we are deriving something new means we should, for example, in 2000, the mobile phone is a bigger size. Okay. Bigger size and weight is also very large. And nowadays it is very thin and it is also some very fancy styles is also available. What we did here is we make the smaller and smaller and we are going in a compact zone. Right here also we are Newtonian mechanics is already exist a long back, and why we need this Lagrangian or why we need it Hamiltonian is we want to simplify the equation or the set of rules such that we can make the easiness of solutions of the particular system. Okay, that is the main ultimate goal for this whatever the techniques we are deriving in a classical mechanics or quantum mechanics or statistical mechanics. So our based on the initial conditions, we should follow the solutions of that motion. If, for example, if you take one object is moving from here to here, the equation of motion is same, right? This is one particle. If another object is moving from this point to another this point, then the motion is equation is same, but the initial position is different. So where it will be at initially, that is very important to derive. Once you derive the equation, and after that we should identify where the initial conditions for that. Then only we should know at after certain time t where that particle could be existed. Right. So the initial conditions is also very important for our understanding and as well as to identify the position of that particular object at a later time t is equal to some capital T. So these are the simple things. And another important in a classical mechanics or any mechanics is conservative systems. So if you understand fully the conservative systems, then you can able to solve an n number of problems irrespective of whatever the technique you are utilizing, whether you are using the classic this Newtonian technique or Hamiltonian technique or Lagrangian technique it is. So generally we have three conservative systems are there, or conservation laws are there, symmetry or conservation laws. Uh, if you are taking the linear momentum is conserved, linear momentum is conserved, as you know, the spatial invariant, spatial invariant. Okay, what do you mean by spatial invariant? So if use x is a position, if x is moving to x plus x delta xi or epsilon, there is no change in that position, or there is no position change in that Lagrangian. Okay, or the position is invariant, or it will be same thing is came into the picture, then you can say the spatial invariant. If you are rotating the object, if you x plus theta plus delta theta is equivalent to the theta, then theta of theta is varying, theta of theta plus delta theta or epsilon, then the rotational variation is invariant. So if a rotational invariant, then the respective momentum is also invariant. That will be said whether it will be a linear momentum or angular momentum, that will be based on the spatial invariant, or it will be uh, spatial invariant or spatial homogeneity. Homogeneity. So whatever it will based on that, it will be changed. If it is a rotational, then it will be angular momentum is conserved. It is a linear, then it will be linear momentum is conserved. If your time is invariant with respect to the system, then the total energy is a conserved. So that is you already know. So if you are taking one example, for example, one particle is moving. I'm not going to derive any equations or any other things because you already known for that. So I will go into this straight away some few examples which can be little tricky, and it might be useful for your preparation. Okay. So if for example, a particle is of mass m, particle of mass m is moving along a trajectory is given by x equal to x naught cos omega 1 t, and also y equal to y naught sin omega t. So sin 1 sin 2 omega t, sin 2 omega t. The particle is moving is with this trajectory. Now we're asking find the x and y coordinates or components of the force and determine the condition for which a force is a central force. Please, the question is, they are giving the mass is m and it will be follow the trajectory x and y, and they are asking to find the force of the f of x and f of y. These components they are asking, and also they are asking whether if the for which the force is central. So if it is a central force, what is the condition for that? So how you can solve this one? Please take the paper and you can try to solve, and you can post the answer for the same. So definitely there is no problem to find out the components. How you can find? So we should need to F is equal to ma. A is acceleration. So in both direction, x and y direction, we should need the acceleration of that particular object. Then you can find the force components, right? So what is that final answer? Please take a pen and paper and try to solve the same and post in that chat box. Okay. So the final answer for this is minus m double one m omega 1 square xi plus omega 2 square yj. I hope you also get the same. And if you suppose we will take now the condition for the central force we have this one. So when you can say that it is a central force, then we should be follow some certain rules again. Then only you can say that F is a central, right? So it should be F should be the function of R, and also F of R is acting along the axial direction of two particles. If you are two particles is rotating one and the other in a central force field, the force is also the line joining in between the two particles. The direction of the force should be in the line joining in between the two particles, and also it will be a function of R alone, right? So when it will be, the force can be said as a, this type of function can be exist. So the first condition should be, you should take omega 1 equal to omega 2 equal to omega. Both x and y component rotation should be constant, should be same, not constant, should be same. So that I can treat it as omega 1 equal to omega 2 equal to some omega, right? If that I will substitute, F is equal to minus m omega square, right? Xi plus yj is there. This how I can written as, this will be R vector. So minus m omega square R. So can you say that this force is a central? Yes, why? Because this can also follow part we need to satisfy the condition for the central force. So if they are asking what is the condition for this force as a central, immediately we should know omega 1 equal to omega 2 equal to omega, some another value omega. Right? And from this you can easily find out, there is no doubt, potential energy U. So how you can find the potential energy? If you know the force, the simple formula is there. So F is equal to minus del V del U, and then you can substitute that values whatever you know, then you can easily find out the force, right? So U equal to some 1 by 2 m omega 1 square plus omega 2 square y square, it will become plus some integral constant will be also come. So please remember, whenever you are doing some problems in the competitive exam, so these small things also we should need to understand. So based on the what statement they are giving, then you can choose the appropriate answer. That is very important. Everybody they can do the things. So F is equal minus del U, and they can find out the potential energy. There is no doubt at all. But based on the what question they are asking, so we should identify the appropriate answer for this thing, right? Here the constant is there. So this constant, when it will be 0, if at the origin, it is started from the origin, the particle started from the origin and it will be moving, then at the initial state or at the origin, the C is a constant. Okay, so the conditions where they are using that initial conditions, they should take into the picture, then you can substitute and you can find the C value also. So then only your answer is correct. Okay, so please, this type of problem you should try to find these things, and you should remember that thing also. And how to find the total energy of the particle? So total energy is a function of kinetic energy plus potential energy. And you know the x component and y component. From that, you can find the velocity terms. And you already know the potential energy. Then you can substitute in the E value, E is equal to T plus U. Then it is equivalent to, so sine terms, cos terms will become, so sine square plus cos square theta equal to 1. If you are using that equation, finally you can get 1 by 2 m x dot square omega 1 square plus y dot square omega 2 square, it will become. Right? Whether this energy is conserved or not, that is also very important. We should remember. If here energy is conserved or not. Why? Because there is no external force acting into the system. Immediately you can say that the energy is a conserved. Okay, from our basics of Newtonian mechanics, we can easily say that this energy is a conserved. From Lagrangian again or Hamiltonian, who will say that if the energy function or Hamiltonian is explicitly not depending on time, then you can set that Hamiltonian of a function is a conserved. Here, h is equal to E in this case. H is equal to E in this case. And E is there not depending on time. And you can easily set that it will be constant. We have one down. Omega is there. And omega is a function of time is also because theta of t. Why it is a conserved, right? So, but omega here is a constant value. With that constant, it will be vary. Okay, and and also there is no external force acting into the system. Immediately, you can also set that it will be a conservative system. And this is one simple example where we can connect from the classical Newtonian mechanics, and as well as you can also take into the picture of Hamiltonian or Lagrangian. The same thing you can solve. So one thing you remember here, whatever the after integration or multiplication, there will be some constants are coming that you should be identify with the based on the initial conditions of that particular system. So then only your answer will be correct. So you will take a simple another example. Another example, a block sliding on a movable frictionless inclined plane. Please read it and try to draw the diagram. So in a classical mechanics or any mechanics systems, once if you see the statement, you are able to draw the diagram for the same, half of the problem is solved. There is no doubt at all. If you correctly draw the diagram, what they are put at the question or statement, then you can understood what they are giving. That means you know the basic things of the classical mechanics. So once you understand the basics of that one, and later part is not much difficult. It is not much fun. So please take into the this statement and try to draw the diagram, whatever you understood. It is a basic thing only, not much thing. So this is a simple diagram of above. It's a little vary and little bit variation here. Frictionless inclined plane. This is the little variation it is there. So the object is moving on the inclined plane. The mass of the small object is small m, and the mass of the inclined plane or that wood is the capital M. The inclination is theta. Inclination is theta. And also it will be a moving in this direction. The wood is also moving in that particular direction. So two things we should. So object is moving and also this is there in that particular direction. So how you can find the Lagrangian equations of motion. First, we can find the Lagrangian L for this particular system and determine the acceleration of that particular object. The question is find the acceleration of the object, moving object, M. Suppose it is x dash and it is x. These other things are looking like identify easy. So how we will find? So first we should know what is Lagrangian. There is no doubt. So once you know the Lagrangian and how to determine the Lagrangians for any system, that you should understand. So for that, there will be a few steps are there to find the Lagrangian and also solve the problem by using the Lagrange. Right? So that steps you should remember when you are going to solve like these problems. First, we should find out, select the appropriate independent generalized coordinates. Right? The first step is, so we should select independent or generalized coordinates is meant that independent only. So generalized coordinates. First, we should select the generalized coordinates. The second one, the second step is, and you should find out the forces acting in the system. What type of forces acting in the system? Right? The forces, what type of forces acting in the system? So like whether it will be a conservative force, or if it is a conservative force, or it will be velocity dependent electromagnetic force, or it will be holonomic constrained force, or it is a generalized force. Right? So the whether it will be conservative or it will be non-conservative. If it is a non-conservative, whether it is a velocity dependent or if it is a conservative, holonomic constrained conservative force, or it will be a generalized force. So first we should understand, or first we should identify what type of forces acting in the system. And the next step is the set of, once you know the thing, then you should need to minimize the generalized coordinates. So if you are taking this system x, y, z direction, it will be there. So generalized coordinate, you can take x, y, z also, right? So we should need to minimize the generalized coordinate. That is very, very important step. Minimize or minimal the set of generalized coordinates. That is a next important step. So minimize generalized coordinates. So we should know how many constraints are existing in that particular system. So once you know the constraints, then you can easily find out how the minimum number of generalized coordinates. Then you can derive the Lagrangian based on the equation. Derive the Lagrangian. How you can derive? We should find the kinetic energy and we also find the potential energy. So kinetic energy you can find based on the generalized coordinates. How are you? If your x and y is the generalized coordinate, then it will be of one mass system. It is there, x dot square plus y dot square. If it's two mass system, m plus acceleration of that and y m2 plus acceleration of that, it will become in a whatever the direction it will be. And potential energy is there. So which direction it will be existing, then you can find out whether it is a mgx, mgr or whatever it will be. So finally, once you know the Lagrangian, then derive the equations of motion based on the Lagrangian equation. So if you have n number of Lagrangian, n number of coordinates, that number of Lagrangian equations you can generalized coordinates if is n, then you can get that number of generalized equations dl by dou l, sorry, so q dot and dou l by dou some force. There will be a variety of equations are there. Again, it here the force is here I am writing why, because whether it is a conservative force or non-conservative force, if it is a conservative force, this term is not existing. If it is non-conservative force, the generalized force also should come into the picture. Okay, so we should need to follow this step. But if you are going for a competitive exam, it is difficult to follow to all the steps. So in your mind itself, everything you should do in a fraction of seconds. What are once you can see the system, we should identify generalized coordinate immediately, and we should minimize the generalized coordinates. And you should also know what is the kinetic energy and part of a potential energy. Straight away, you can try to write down the Lagrangian of that particular system in two terms, kinetic energy and potential energy. So after that, you can, whatever they are asking, based on that, you should identify the equation of motion or the conservative, what is the conservative forces, or if you want to acceleration, that you can identify. Right? So these are the a general strategy to solve the Lagrangian equations. But when you are solving the problem in a competitive exam, you should find a straight away to the Lagrangian. Why? Because other things you can do yourself within your mind, and you can easily, from the diagram itself, you can easily identify, skip from the one to third step, right? So coming to the our problem, what is the Lagrangian for this system? Here, two particles are there, capital M and small m, right? So from capital M also have some potential energy, small m also have some potential energy, right? So you should try to find out the Lagrangian for this system. L is equal to, sorry, so L is equal to, sorry, okay, here I will write L is equal to, L is equal to 1 by 2 capital M x dot square, because here capital M is also moving in this direction. So the acceleration is x dot, sorry, x dot square. So m x dot square is the potential and, sorry, kinetic energy of that particular system, only the mass m. And now you are coming into the second particle, the kinetic energy should be multiplied with the small m, and that will be, should be x dot square plus and x dot, this is small. Why? Because this displacement is also effect on this small m, and x dot square plus 2x dot and x dash dot cos theta plus this is the potential energy, kinetic energy. So now you want to potential energy only because of this mass alone, not this mass is involved the potential energy, because we are treating as this is a grounder. So we will take that one. The potential energy U is equal to mg x dash sine theta, height of that particular one. mg x dash sine theta, right? So from that you get the L value. So you can use the dx by dt Lagrangian equation along the x-axis. the generalized coordinate x, then you can find out what is the equation of motion. So here we can say that there is no force is acting. So the total linear momentum is in the system along the x direction is constant along the x direction, because along the x direction there is no force acting into the system. So this direction, the linear momentum is comes out from the Lagrangian equation. You can easily find. So the same thing you can also predict from the Newtonian mechanics also. There is no, whatever you are thinking, whether you are doing the Newtonian mechanics, Lagrangian mechanics, other things, the final solution or final solution of that particular system should be same. So these all are the way of techniques who can achieve that particular way or particular solution of that particular system. And if you want to find the acceleration of that particular system, once again you can take the Lagrangian in terms of x dash, then from that you can easily find out here x dash term is not there, so it is a cyclic coordinate again. I hope you remember what you mean by cyclic coordinate. If any function, if is any coordinate, if x, y, z, or so on, it will be there. It is a function of some coordinates. If the coordinates is not depending on Lagrangian, then you can say that quantity is cyclic in that particular system. Once the coordinate is cyclic, then the respective conjugate momentum is a constant that you already know. So based on that, you can easily find out the acceleration of that particular system. The final solution for this system is x double dash is equal to g sine theta divided by 1 minus m cos square theta divided by m plus capital M. This is our acceleration of that particular system M. Okay. So this is the way how you can find some problem in that block sliding on movable frictionless inclined plane. If you are again consider the friction, then it will be again very difficult to find out the equation of motion. Why? Because non-conservative forces is also acting in the system. So we should add up this Q quantity in the right side. So additional forces you should add up. Then you can solve the equation of motion by utilizing the Lagrangian. Right. Next problem is, sorry, itself here I feel. 1 minute. Yeah, okay. Okay, next problem is a simple pendulum. This also you know. So you can just try collecting the things, and I am trying to extract what things are important when you are solving the problem. That I am trying to give some idea, nothing else. This also you already know. There is no doubt at all. Simple spherical pendulum is not a simple pendulum. A spherical pendulum, if you are considered, then you should consider in x, y direction also, right? So if you are taking this spherical pendulum problem, then again, that 5 steps are there. First 3 steps from this diagram itself, you can identify, and you can, once you know this diagram, that first 3 skip, and finally you can write down the Lagrangian itself. So if you try to write the Lagrangian, sorry. So Lagrangian for this system, please try to write down the Lagrangian for this system. And before that, you can find the potential energy and also the kinetic energy. It is a spherical pendulum. So here I given two coordinates. So How you can take this one? We will go for the Cartesian coordinates or cylindrical coordinates or spherical coordinates. So that cleverly you should select. That is another important note when you are solving the problem in a Lagrangian and Hamiltonian. The appropriate coordinate system you should select. Then only the problem it is easy to solve. Okay, this the same thing you can take in as a Cartesian coordinate also. But the problem is, again, the solution of that problem is not so easy when you are solving. So we should take in a spherical coordinates, then it is easy to solve. So the first important thing is we should select the appropriate coordinate system for any problem. So if you are taking here the spherical coordinates, the L is written as Lagrangian. L is equal to 1 by 2 m. M, we are taking the mass of this bar. 1 by 2 m v square theta dot square plus 1 by 2 m v square sine square theta pi dot square. Pi dot square. Why we are taking it will be two-dimensional motion. It is not a simple one-dimensional motion. Spherical pendulum we are taking. And also we are taking the reference point here. Sometimes somebody they will take the reference point here also. So based on the reference point, the potential energy is also vary. That is also very important where you are taking the reference point. But it will be ultimately the final answer should be same. There is no doubt at all. And what is the potential energy? Potential energy, this is the reference point. It will be negative y direction. So it will become minus mgb cos theta. mgb cos theta. So Lagrangian minus and minus plus it will become. So plus mgb cos theta. mgb cos theta. So we know this written, this one is simply in one step. So now if you want to solve this problem and what are the components are conserved in this system that we should identify. So here, what is the constant of whether it is a movement, what type of momentum is conserved? So based on the cyclic coordinate, the simple cyclic coordinate behavior, cyclic coordinates, if you are identified, then the respective conjugate momentum is conserved. Respective conjugate momentum is conserved. So here, which one is the cyclic coordinate? Pi is the cyclic. Pi is the cyclic coordinate. So the respective angular momentum p pi should be conserved. Should be conserved in that particular direction. Pi direction, the angular momentum is conserved. The angular momentum is conserved. This also same. Why? Because in that particular direction there is no force or there is no torque acting in the system. But in direction of pi, there will be a force acting. What that force? Mg. Force mg is acting, or tension is acting, or torque is acting along the theta direction. But in pi direction, there is no force is acting. Because of that reason, p pi is a constant. P pi is a constant of motion. And there's a whether this is a total energy is a conserved or non-conserved. That is also we should identify. So here L is explicitly not depending on time. Then you can easily set that L is a conserved. In other words, there is no external force acting into the system. or there is no outward force or inward force is existing. Because of that reason also you can say that the total energy is also conserved in this particular system, right? So how this thing you can represent in a space diagram? That is, the space diagram is a one which can be represent all system equation of motion in two-dimensional representation. So that will be very useful if you are dealing more than one particle. Okay, and it will be easy to understand the motion of the object at any instant of time. Okay, the graphical representation of equation of motion in the generalized coordinates are q comma p, and generalized coordinates p comma p. So if you are taking all generalized coordinates q's, qi's in x-axis, all generalized momentum pi's in y-axis, then you can draw the the diagram that can be represent the equation of motion or the behavior of that particular system at any instant of time. Once you know the initial condition and you know the Hamiltonian of that particular system, then at any instant of time, you can easily find out the motion of that particular object. So next the task is please try to find out the Hamiltonian of this particular system. Hamiltonian of this particular system. Please try to take the Hamiltonian, try to find out the Hamiltonian of this particular system. And for easiness, the P is a conservative. So that quantity you can also eliminate. There is not a problem. So please first we can find the Hamiltonian of this system and try to draw the space diagram for this particular system. Maybe you already know. There is no doubt at all. This is a general problem. Everywhere they can explain or they can solve this problem during your classical mechanics course. So here I am trying to ask, just you can recollect and try to write the Hamiltonian and also try to draw the space diagram for this particular system. Okay. So this everything we should do within a 2 to 3 minutes. So that is the challenge when you are appearing for competitive exam. So most of the guys, they may know the concept and also they can be able to solve when they are in the classroom. But when you are performing the exam, like in a GATE or CSR, the time, because of lack of time management, they are selecting a wrong answers. So there should be, mind should be concentration, and whatever our weakness should be controlled, and we should manage our time during that problem solving. That is very challenging when you are appearing for any competitive exam or any interview. Okay, once you can control the weaknesses and whatever you know that you can express in a systematic manner where you can easily succeed whether it is interview or it is an exam. So everyone, they don't understand 100% and they don't know everything. There is no doubt at all. So the main important thing is at a limited time span, what you are understand perfectly and how you are controlling the things and how you are managing the time and how you are solve or you are expressing whatever you are understand. So that is the easy when you if you are express whatever you know in a systematic manner during the interview, it is that is the success of your interview. There is no doubt at all. So in field, of the field, it is a different situations. So that pressure should be controlled and you should manage that time. So here also you can take. So please try to draw the space diagram. I hope you can get like this. I hope you can get this like this. Is it correct? So here many points are there. If you are taking the simple pendulum, it is moving, right? In general. But when you are taking the space-based diagram, like you are moving up to here, theta is varying from 0 to pi. Why here pi, this moment is not appear? Why it is not appear? Because it is a conservative. Because it is a conservative, it is always constant for that particular system. So there is no need to represent in a space-based diagram, right? There is no need to represent a space-based diagram. So here the pi is varying 0 to pi up to here. And also if you apply more energy, then what happened? It is also complete one rotation. Also rotate one direction. So that means pi can be variable from 0 to pi, and also it can be variable from pi to 2 pi and so on. Right? When if you are taking the energy, some this much enough energy if you are giving, then it will be rotate in this region, right? So it will be somewhere here. If you are giving more energy, it will be rotate the entire region, then the space-based diagram is entire this region. Right? And so on. The direction is also important. Which direction you are applying the force? Okay, whether this direction or this direction, that is also very important. So like that, based on the initial conditions, these loops will come. And based on the energy also. Here loops is means theta is vary, pi the p pi is also vary. That means energy is also vary. So the first one is the energy in between mgl less than mgl, E less than mgl. If that is the in that region less than mgl, then it will be in a circular motion, and it is a in another square type. It will become when spheroids type will come when mg equal to E is equal to mgl. This is the equal to mgl. So if you are more energy you are giving, it might be escape from your system. And it will be come back if it is a central force fields. So half of the things will come. So if you are taking the entire system 0 to 2 pi, then the repetition, the same thing is repeated because it is a symmetry repeated in both direction. Along this axis, it should be symmetry. Along this theta, because along this axis, this system and this system should be same because the symmetry is existing. So the same is up here. So hyperbolic point is here and elliptic point is here. Okay. So based on this system, you can easily, if you know this space diagram, then it is easy to understand the entire system of the things also, right? So next is this problem is also you know. So I'm now this one is as a homework. A mass and a frictionless plane connected to plane pendulum. Plane pendulum. So you can take this example and try to understand the space-space diagram also if possible. And also you can try to find out Lagrangian and equation of motion from Lagrangian, the Hamiltonian and equation of motion from Hamiltonian. How many conservative forces are existing or movement or linear, sorry, how cyclic coordinates are there. Based on that, you can identify the conjugate momentum for that particular system. So next, another important problem is this slide problem. This also you in Newtonian mechanics you solve this one. There is no doubt at all. But look on it. Look on it. There will be three masses are there. Three masses are there. And they are hanging a linear momentum is outward mission style. Outward mission. They are showing the figure. And here, assuming that linear momentum is conserved. So assuming that linear momentum is conserved. Assuming that linear momentum is conserved. Why? Because if you are not conserved, again it is a complex problem. Assuming that linear momentum is conserved. So now you can try to find out the Hamiltonian of the system. How you can find? So if you are how you can find this Hamiltonian? Or if you want to find out what is the conservative in the system, what is the conservative? For example, if you take first we can find out Lagrangian, then I can discuss what I'm taking. So try to find out Lagrangian for this system. So not much difficult. Please try to understand the concept and try to get the kinetic energy and potential energy for the same. For this three mass system along the x direction and y direction. Along the x direction and y direction. Middle point should be taken as x plus y. Okay. Along the x and y direction, you can take it the what is the mass length, you can take it. And here they are asking what is the conserved quantity for this system apart from the linear momentum. So that linear momentum is conserved is said, right? What is that particular quantity? So they are giving some different values. So for example, m 17x dash plus 10y dash is one answer, and m 15x dash plus 10y dash is another answer, and m 17x dash plus 15y dash is another answer, and so on. There are many. So which is correct answer? How we can get it? Right? There you have n number of ways. You can use either Newtonian mechanics, Lagrangian mechanics, or Hamiltonian mechanics. Whatever you can like. The answer you should send. And if like this, it will be game. It is take some more time also. First, you can try to write down the Lagrangian. Try to find the Lagrangian. So if you are, I'm not going in detail, but final answer for Lagrangian is 7 by 2 m x dot square plus 3 m x dot y dot plus 2 m y dot square minus potential energy mg x minus 2y. This is the final answer of that particular system with respect to Lagrangian of this one. So now you can find out which quantity is conserved, which linear quantity is conserved, what quantity of linear thing is conserved. So here two ways are there. One way you can use Norton's theorem. Norton's theorem states that again the conservative quantity with respect to translations, whether it is a linear translation or rotational translation, or it is a time space translation. So based on that, you can easily find out that one, right? So we can see here, the question is we should find out which quantity is a conserved, right? They are not asking any equation of motion or anything. If you are solving the equation of motion and it will be do, then it take a long time. So here cleverly you can use the Norton's theorem. Norton's theorem. So where the conservative of momentum or angular momentum, whatever is defined in terms of space or in terms of homogeneity, or whether it is a space homogeneity or a time homogeneity or and so on. So here linear momentum is conserved. They already stated, right? So that quantity we should identify. So x, if you are taking in this equation, x dot x naught plus 2e, and y you can take in as y naught e, y naught plus epsilon, y naught plus epsilon. Then Lagrangian is independent on epsilon. You can see that if you are substituting x is equal to x naught plus 2 epsilon, y is equal to y naught plus epsilon, then a Lagrangian is independent of epsilon. That means dl by d epsilon is constant, should be 0. So that means this independent smaller perturbation value of epsilon, the Lagrangian is invariant. So if that is the true, according to Norton's theorem, P epsilon equal to rho L by rho epsilon dot should be conserved. Should be conserved. So how you can find this value? That is the important task. So P epsilon equal to rho L by rho epsilon dot, that is equal to rho L by rho x dot, rho x dot by rho epsilon dot plus rho L by rho y dot, rho y dot by rho epsilon dot. Can I write this? Right? So we know this. You can easily find out this from the equation. And this also you can easily find out this one. And this one you can find out from this equation. You can easily find out that equation. asking, it is easy for you. So if you are going in a simple rude way, then it is very difficult to solve this problem, right? What I am trying to convey here, you should even you know the variety of methods, but smartly you should select the appropriate one which can be easy to solve the final output of that particular one, because the output is what they are asking. Based on that, you should select the method of approach. Okay, that is very important. So Hamiltonian, like in its Lagrangian, this is the way how you can find the Hamiltonian. And that Hamiltonian also, if two things are there, Hamiltonian, if dt by dh, if it is the condition is satisfied, then the time dependent independent two cases are there. If time dependent cases, h is a conserved, and the time independent case, h is a not conserved, right? And the time behavior in the Hamiltonian, h is explicitly depending on t, then you can say that dh by dt equal to minus dou L by dou t, but not equal to 0. So if time is explicitly is this there, then h is not conserved. Maybe is h is equal to e when is the time independent, and even time dependent, then it will be h is a not conserved and h is not equal to e. So these four conditions are existing for any system. Either one they should follow, right? Whether it is a conservative or it is a non-conservative, or h is equal to e, or h is equal to not equal to e. These four combinations should be followed in any one of the system. If you are taking a simple pendulum, there is no external force is acting on the system, then h is independent of time, and h is a conserved, and also h is equal to e. If you are taking the bead is moving on a string with a rotation omega, then there will be system is non-conserved, and also E is equal to not equal to H. So like that combinations it will become. So whatever the things, these all the things will be existent. Here one example is you can take as a homework and try to solve the same. So consider a linear harmonic oscillator on a car moving at a constant velocity, moving a constant velocity v naught, and in the along the positive x direction, right? Now the question is, find the Hamiltonian of the system, find the Hamiltonian of the system, and also find the conservative things which is present in the system. Okay, so that also you can try to find out. Hamiltonian we should find out. Here two ways are there. One is the hard frame, one is the hard frame, another one is the laboratory frame. Hard frame and laboratory frame. If you are going in a laboratory frame, lab frame, then h is equal to p square by 2m plus 1 by 2k x minus v naught t whole square will come. X naught whole square will become. And the same thing if you are doing in a chord frame, same thing you can doing in a chord frame, then h is a function of x dash prime p dash prime comma t, and it is equivalent to p dash minus mv naught whole square divided by 2m plus 1 by 2k x square x dash square minus 1 by 2 p dot square. This is if you are considering a chord frame. So please, what they are asking, based on that you should select whether it is a lab frame or chord frame. Then only you can get the appropriate answer. Then only you can get the appropriate answer. So here H is a conserved and H is a total energy also. Sorry, not total energy because T is involved. Okay, H is conserved but is not total energy. H is a conserved but H is not equal to E, total energy, because H is a function of time. So please remember or note what they are asking. Based on that, you should try to solve the problem, whether it is a code frame or lab frame. Okay. So that is a very important note. And here I noted some previous CSR or net problem, few problems, not many. I will share these things. You can get it in internet also. There is no doubt at all. So the first problem is the particle of mass, unit mass moving in a potential energy where A and B are positive constant. Find the angular momentum of small oscillations about the minimum of potential energy. So how you can find? What is the answer? What is the answer for this? Please share your answer in the chat box. Please share your answer in the chat box. How you can find minimum potential energy? Where it will be minimum? So minimum means dou V by, sorry. Minimum means dou V by dou X should be 0. Dou V by dou X should be 0. Should be 0. And X naught is stable equilibrium point. If you are consider X is equal to X naught is a stable equilibrium point, then omega value will come. Omega value will come. Omega is equal to square root of K by M, where M is equal to 1. How you can get the K is another important task. How you will get the K? K is equal to dou square V by dou X square at X is equal to X naught. At X is equal to X naught, where X naught is the stable equilibrium point. Stable equilibrium point. So how you can get X naught? From this equation, you can get the X naught equal to V by A whole power 1 by 4. So here the thing is, we should remember it is a minimum potential. At that minimum potential, what is the frequency? So minimum means this condition is existing. So from that you can find out the X naught, and omega is equal to square root of K by M. M is equal to 1 because unit mass, and K is related with the potential energy. K is equal to dou square V by dou X square at X is equal to X naught. Simply you can substitute, then you can get the answer. So that will be B, square root of 8A. Right? So everything they are giving in the problem statement, please try to understand and utilize the appropriate equations. Then you can find the solution for the same. Okay. So next simple problem is this one. The acceleration due to gravity on the surface of Earth is approximately 2.6 times that on the surface of Mars. Given that the radius of Mars is about 1.5 of radius of R, the ratio of escape velocity on Earth to that on Mars is approximately. This is simply based on the Newtonian mechanics or rotational motion escape velocity problem. And it will be came in the NET 2011. So what is this answer? We should know the escape velocity formula. That will be square root of 2gr. 2gr. G is the gravity, R is the radius. So we are divided by mass. That means square root of GERE divided by GMRM. Mass, E means earth. Simply you can do it. Then ratio you can easily find out. Ratio you can easily find out. It is equivalent to 2.3. That means C is the answer. So next is this one. Lagrangian of a particle of charge E and mass m is applied electric and magnetic field is given by Lagrangian L is equals, they are already given, where A and pi is the vector and scalar potential corresponding electric fields, electric and magnetic fields. And which one is the correct answer, correct statement? So which one? The first one is they state the canonically conjugate moment about the particle is given by P bar is equal to mv. The second statement they are given the Hamiltonian of particle is given by that thing. Simply they are putting the plus and minus and they are add up. And L is remains unchanged under Gauss transformation of potential. Third one is under the Gauss transformation of the potential, L changes by the total time derivatives. Which one is correct answer? So D is the correct answer because there will be Gauss transformation, potential L change by total derivative. Gauss transformation invariant. This is another problem. The Hamiltonian of particle of unit mass moving in xy plane is given to be this thing. The initial values are given during the motion. So maybe I am little past because the time is also escaped. So please, what I am trying to convey is that please try to understand the problem and use appropriate equations respective to that, and you can find the correct answer. Okay. So this is another problem. You can also get this one is from previous CSR net shows. And this what we discuss in our class also. Today's class also. What is the correct answer for this? First we can find out what is this. The potential moving in one dimension potential, and which of the following curves best describe the trajectory of this system in space-based diagram. What is this actually? So C is the correct answer. Okay. So with like that, many other problems also there, right? So like this, it will be there. I will share later. So with this, I will stop here for this today's lecture. And thank you one and all for your patience. And it is not easy to listen in the online mode, definitely. So even though you are giving some time and you